C30B is about Pythagorean theorem for triangle classification. The first definition we have, it states that three segment links create a triangle if the sum of the two smallest links, three segment links create a triangle if the sum of the two smallest links is greater than the third length. The next definition is a Pythagorean triple. This is a set of three integers whose lengths will always make a right triangle. And there are a few examples of these that you will see quite often, and these include 3, 4, and 5, 6, 8, and 10, 9, 12, and 15, 12, 16, and 20. And one more you might see is 5, 12, and 13. There are many more Pythagorean triples, but these are the first 5. The next section, there's going to be 3 different parts. I'm going to put these in different colors to classify them. The first statement says that if a squared plus b squared is equal to c squared, then the triangle is right. So basically, if Pythagorean theorem is true, then the triangle is a right triangle. And here we are saying that A and B are the short sides, and then C is the longest side. The next statement is stating that if a squared plus b squared is less than c squared, then the triangle is obtuse. So if the two short sides, if a squared plus b squared is less than c squared, then the triangle is obtuse. And the last statement, you can probably guess, states that if a squared plus b squared is greater than c squared, then the triangle is acute. So those are the 3 scenarios. The triangle can be a right triangle, an obtuse triangle, or an acute triangle, depending on Pythagorean theorem. Okay, the next table gives us segment lengths and wants us to decide if it can form a triangle and why we think that, the work to back that up. So the first segment lengths are 5, 8, and 16. In order to form a triangle, we need to go back to our first definition here. So it states that 3 segments can create a triangle if the sum of the two smallest lengths is greater than the third length. So our two smallest lengths here are 5 plus 8, which gives us 13. And 13 is less than 16. So to form a triangle, the sum of the two smallest lengths must be greater than the third length. Here, 13 is less than our third length. So that means that no, these segment lengths do not form a triangle. The next one, our two smallest lengths are 4 and 7. If we add those together, we get 11. And 11 is larger than 9. So yes, 9, 4, and 7 can form a triangle. And the last one, our smallest links are 6 plus 7, which gives us 13. And 13 is equal to 13. So our definition says that the two smallest links, the sum of the two smallest links must be greater than the third links. Here they're equal, so no. These segment links cannot form a triangle. A triangle has side links of 5, 12, and 13. What type of triangle is formed? So we need to use these statements to figure out what type of triangle we have: a right triangle, an obtuse triangle, or an acute triangle. So if we take our two smallest links, we have 5 squared plus 12 squared. I'm going to leave a blank space here because we don't know if this is going to be equal, less than, or greater than. 25 squared we know is 25. 5 squared is 25 plus 12 squared is 144. Something 13 squared is 169. 25 plus 144 is 169. Our blank, 169. 169 we can fill in this is equal to 169. So whenever a squared plus b squared is equal to c squared, we're going to use our first statement, and that tells us that we have a right triangle. Okay, the next one has side links of 4, 6, and 8. So we're going to do the same thing. 4 squared plus 6 squared, something 8 squared. So this side gives us 52 blank 8 squared is 64. So 52 is less than 64. So if we go back to our statements, a squared plus b squared is less than c squared. So we're going to use our middle statement telling us that we have an obtuse triangle. And last one has side links of 5, 6, and 7. So we're going to, again, 5 squared plus 6 squared, blank 7 squared. On the left-hand side, we get 61 blank 7 squared is 49. So we know that 61 is greater than 49. And if we go to our statements, a squared plus b squared greater than c squared gives us an acute triangle. All right, and our last question here asks, you have 3 pieces of wood measuring 3, 5, and 6. Can you create a triangle with the 3 pieces of wood? If a triangle can be formed, what type of triangle would it be? So the first thing that we need to check is if this triangle, or if these pieces of wood can even form a triangle in the first place. So for that, we're going to use our first definition, that the sum of the two smallest links has to be greater than the third. So that means 3 plus 5, that equals 8. That must be greater than our third length, which is 6. So yes, it forms a triangle. So it's asked, if a triangle can be formed, what type of triangle would it be? So now that we know that yes, it can be a triangle, let's figure out if it's going to be right, obtuse, or acute. So we need to do 3 squared plus 5 squared, blank 6 squared. 3 squared is 9, plus 5 squared is 25, blank 6 squared is 36. 9 plus 25 gives us 34, blank 36. 34 is less than 36, So that means that we have an obtuse triangle formed from these 3 pieces of wood. And that concludes 30B.